Hello, guys. I'm in software development. Today we are discussing about the Uber system design so that you can explain in interviews. We will walk you through what should be the steps that you should apply while telling to the interview your approach. Alright, let's move on. Let it go. Today, right. I hope you can see my screen. Yes. So, we all know what is an Uber. Uber is a platform where you can ride from one location to another location. There are some drivers available who help you to reach there, right? So um, this this part will be intro focused and will tell you the real production concepts in this class. About some high level and low level system design that include topics like Redis, GEO, Kafka, limits, things like these, and how we scale the systems. Right. So let's move on. Right. So in the high level design, what our app does. So it's an there is a rider. Suppose you are a customer, you want to go from here to another location, right? And there should be a driver who helps you to reach there. So, what should be the high level flow? That there should be an rider app, just like a customer app, right? And let's suppose you tap on book ride, right? And there should be an ETA gateway. It's your main backend where that request receives, right? And the ride service is basically to help you to match the driver, finalize the driver, and then driver and help driver to contact you, things like these, right? So it's in ride van and it's a ride service who help you to reach the driver. So ride service, what it do is there should be another matching service and this ride service connect to it. Matching service, what it does is just match the driver for it. So it's matching through the location, right? And there can be separate location for you, so it just can be implemented in the same matching service, right? So we store driver locations in Redis in GEO form. GEO basically nothing but just the longitude and latitude, and then what should be the next row? Driver. Through the location, you find out the driver and send the driver an event that there is a person who wants to go from this location to another location, right? So then driver accept your request. Ship service is basically nothing but it go through steps the uh, right created driver accepted. Now where is the driver now, and next, uh, write completed, then the payment ID. Let's suppose driver accept. If service means, let's suppose driver complete the ride, right? Now the payment part, there should be another payment service where the customer should be complete the payment. Will show you how the payment service should be connected to the trip service and the another main backend, right? So when it completes, it send an events through Kafka so that we can analyze how things were, notification services. So means it send an event through the Kafka, basically through the produce. There should be a producer and you use the event, and there are multiple services who consume all that event, right, and process it separately, right. Those services should be different, like notification service and analytics service and fraud detection service, things like this, right? So the driver location service, there should be a driver location service, but it do is just should we create an UI for you so you understand very well, or it will um, what do you call this? Alrighty. Mm, okay, we have this. We have this rider report and user that is connected to backend that receive API calls. Here is a dish here, and that backend is connected to the cloud. And here we store things like uh, travel location, GEO, and action. Right. Hexa hexagon is nothing but okay. We can erase whatever. Basically, basically, there are six angles. Like it has four angles, there are six angles. Just like you know, bees home. Just like bees home, there are six angles that are connected to the econ graph. Right? And what is the next? There can be multiple services that do some tasks. And service and it's matching service using detection analytics so that we can analyze what's going on in the for those are connected to different types of right. And all of those all of those should be stateless, so that we can if we want so when we want we can scale the system so that we can handle multiple requests simultaneously. Yeah, like saying like if we want to see now we have two answers and there is load balancer on the request go on here and load balancer proxy door request proxy doors to our backends so that we can handle all of that. Same like we can scale those options also. We just can add on load balancer here also and the parent source can be multiple types. And we also have DB like model specific what it stores. That is super short, right? So the Redis is down. We lost the all the data from here go our backend. Yeah, basically the Redis is down. We can fetch data from the table. The user things like user payment details, payment transaction are usually stored not in the Redis. It's a bit and which services needed also connected to it, like uh, payment service and matching service should be connected to Redis because it just what it needs to do just get the user location and based on that you expect travel you have my package, right? So that is the high level data we walk you through the next slide. Right. The driver location service. What the driver location service do is driver sends GPS every 2 to 3 seconds. Basically, from the front or from the driver, we continuously send a GPS location, their current location, to the backend or to the driver location service. What it do is just store that location in the Redis or just update from the for yeah from the Redis stored coordinates using GEOADD. We already discussed what is GEO is, right? And it is the latest location in key. What is the 2 second? What was the basically current location and the 1 second location? It is stored in the Redis. Redis store data mountain, so it is fast. So fast location can be easily achievable here because yes, so it will take less than 10 milliseconds to look up in the any location or the nearby driver. So it will be cost. Next is Redis GEO. What is Redis GEO is basically nothing but it stores the GEO location some data that let's suppose we have a driver. The location is 77.5 and longitude is this, latitude is this, the driver ID. And when we need to search the drivers from longitude, latitude, let's suppose this sent from the client that this is my current location, find out the nearby drivers. So what you do is where it is in the 3 kilometer radius we find out all the drivers that is there, and so it returns nearby driver instantly. So fast lookup is achievable using the Redis and why H3. H3 is basically why hexagons. Hexagons is we discussed hexagons. This hexagons are saying basically both names are pointing to the same thing, right? Hexagons is that hmm, I think I can create it using the pen. How they look. Talk. Oh, yeah, what's cool? This is the hexagons. And things like this store. Oh shit. There are 3 hexagons that is written. So we can think a map look like this. If I am here, I can find out my nearby locations, and in their hexagons there should be some drivers there, so I can easily find out those. Right? With artists divided into hexagons, basically we can create an overall map using hexagon and attach like this from all the sides. Right. Avoid scanning millions of dollars. Yeah, we don't need to scan all the PP or all the block. We just need to search for more nearby hexagons. Battery scalability, then better scalability than full table scans. So I don't need to scan the whole table. I just need to scan those my related tables, right? Then let's move forward. The nesting service, what the nesting service do is it find out me and driver, and drivers rank by ETA ratings, acceptance rate, version levels in the job. ETA is nothing but key how much far this driver is from you, and rating is previous rating, acceptance rate, how fast he basically how easily he accepts rights, like what types of vision, things like these, and low selected driver could handle booking basically, and booking happen to be first load that driver phone so that um, another booking cannot uh, book the same driver. Basically, two bookings should not match the same driver and accept that driver for all two bookings for the same time, right? So they'll, they will use a locking mechanism that covers. So another tool cannot use it, right? Next, let's move forward. Deep state machine is the whole architecture from searching to government. First, find out a driver for me is basically a searching for me. Then find a driver matched driver arriving basically coming to my location. And before that, from here, here after match, we first we load that driver so that another rubbish candidate should not match the same driver for another booking also, right? And arriving, he picked up that person from his location. And the whole trip is in progress. And keep us here, it should be one by one. It should basically the status should not directly from match to complete. It should be uh, continue one by one. Like, let's suppose now the ride is completed, user have a payment for that ride. Then next, and before payment, there are some fallbacks that we have for some. We'll talk about it uh, in the next slides, right? So let's move forward. After event writing, we use Kafka to send events on another service. See, these are events, not the jobs. Nothing but see, like send this email to that person or no, find out the driver for that job. These are jobs, and events are key. This task is performed, and now do what what is the next thing. Or, you can think about analytics, notifications, and uh, fraud detection, things like this. So there can be multiple topics and we can set like initially when uh, the user book and service, try to book and service to the creative driver, from the driver, etc. There are topics when they completed, we send event from one producer to multiple customers. And consumers can be analytics, service, fraud, fraud detection systems, pricing systems, notifications, service that send notifications to the users, things like these and ML. So what Kafka is? Kafka is an event-driven, we can say, event-driven service, or yeah, that deliver events. Sorry, when the event happens, it deliver and task with task basically. And information. When an event happens, it sends an information to the consumers that this happens. Like, do what is the next step, right? The next thing is failure analysis. This is what I was talking about. For a payment failure, Kafka try Redis GEO. What we should do. Let's suppose we'll talk these one by one. First is driver discontinuous. The driver accept the booking, but now he is gone offline. He cannot come back to the internet. So what we can, for to handle that failure, we can do is the driver basically try to connect per 3 seconds with that, and basically a health check key and available and all. If that cannot happen in, let's suppose, 30 seconds, anyhow it cannot catch from to the backend, then what backend do is just change that booking from one that driver to another driver, because it match to another driver for that booking and cancel from that driver, cancel from that previous driver, because and because he thinks that that driver is going to remove his location from Redis sources. So the next match, so the next matching booking, so the next matching also should not use that driver, right? We didn't accept, we didn't get his heartbeat from the driver, right? And the next is duplicate booking. What if you, let's suppose you click book now button multiple times, so there we use some unique request IDs, like suppose you click and book now button, or book uh, book ride button, and it fails. So what our system do is it try that event multiple times. Because that can happen because of internet issues and other failure. So we just retry, and for those retries, the request ID should be same, so that backend can detect if, so that if backend receives two requests, their result should be same because their ID should are same. So we can we store failures like duplicate booking using these kind of things. Right? The Redis outrage model key, my Redis is unavailable. So we, for fallback, we can also store location time to time in my DB also, so that if the thread is unavailable, so then I can use for my DB and get the information from there. I know it can be it, it isn't that fast, but still I get uh, the actual result, the correct result. Right? And the next is Kafka retry. What if the Kafka fails or the consumer cannot accept the task? We'll try 2 3 times per 2 seconds, 3 seconds. If the most of your friend can send that task or that information to DMQ. DMQ is that will key that key I tried multiple times, but I cannot complete uh, this. I cannot complete this task cannot, or that consumer didn't uh, get this information. So it needs some. uh, It, it needs these some wrong things happen. Needs some human or human right for the fixes. And next is pay. What if the payment fails? Will you, there are also be the request side involved, potential key, so that we avoid multiple payments for the customer. And yeah, multiple payments for the customer and also should not upgrade or the complete right before the payment. So if the payment fails, we retry multiple times. And if that not complete, we go for we can offer the customer that we can pay after some time. Yeah, right. Then I think if it's failing again and again, there there is need some fixes there, right? So next is user replies we discussed. Potentially, yeah, you need to give discussed distributed loss key when the driver matched. We need to load it first so that another uh, booking should not match the same driver, right? So the overall thing is when you are giving your interview or taking an interview, explain why each component exists, why you add Kafka, why you add Redis, like right, you use Redis for to store locations, geolocation, and so that we can find out my near view driver fast screen and the time should be fast. Time should be less. And why we use the after all is if we if multiple services need the same email, we should uh, a service should not send that event to all the services. So I just add a call for that handle to send that event to the service. I just need to send and that event to the call. It's like these trade-offs. What if we remove Redis? What if we store location in DB? And that With that scales, we cannot update the DB continuously, right? So there are the trade-offs, and we cannot search using like nearby drivers or just hexagons if we are using DBs like nobody Postgres. Like talk about consistency, scalability. We discuss the middle when we are designing our GUI in the accelerator that we they should be stateless so that when we need to scale those services that we don't need to handle the in-memory data. My in-memory data is only stored in Redis, right? So these are stateless. We can scale all the services whenever we want. Consistency. If the payment fails, the next request should get the correct state of that payment, right? When the availability needed, let's suppose the driver go to the next service, sorry, the next location. Even if I get the previous location for 2 to 3 seconds before location, it's fine. So there I need availability, and in the payment section I need consistency. And latency is just nothing else. We, we are updating the driver location again and again, and also sending that location to the user. So there should be latency as much as less as possible. Draw the architecture while speaking, like I did initially with the architecture. I hope you understand that. If not, let me know. And next, yeah, it's done. Alright, guys. I hope you understand that video video of the Uber architecture. And bye bye then.